Welcome to our project site. This is our project site, and here we are working on the phenomena of non-conventional energy sources. Here we have developed a biogas plant, small unit, compact orderless plant. You can see the whole unit. This is our digester, which have a capacity of 300 liter and daily production of 200 liter. Now this is our inlet, and it's provided with one water trapper. This is to prevent the odor coming out from the digester. Let's see it. This is our outlet, and it is directly connected to the drainage. Inlet and outlet both are given connection from the single hole. And this plant working on the pressure difference. This is our gas collection pipe, and both collected in this TGSD. As you can see that slurry inside the digester is of a high dense, and it creates a static pressure of a very high level. So here we have used this iron frame, and the whole unit is mounted on this type of frame. This is our blow-off valve. We are using this blow-off valve at the time of flush out, and when the scum formation happen inside the digester, this blow-off valve is used. When the tap is open, the whole slurry will come out very fastly, and this flexible pipe is directly connected into the drainage.
Human have a teeth, but digester have doesn't teeth. So we have to prepare liquid slurry from the food waste. Here show that this is the liquid slurry we made from the food waste. I show you how to feed the slurry. I show you that how to slurry works. When slurry inside the digester, it is fermented in it and produce the methane gas, which is collected in the storage tank TGSD. The critical condition with working food waste is scum formation. Now there are the two ways for remove the scum formation. One is the blow-off valve. When scum formation is happen, we remove some amount of slurry from this digester, so reduce the scum formation. But precaution is better than cure, so we produce one stirrer in the digester. When it steers slowly slurry, then remove the scum formation.
The temperature between 30 degrees to 40 degrees Celsius is important in achieving steady production rate. Here we develop in winter condition. There is a temperature is 20 degrees Celsius below. So we develop temperature control unit. Look at see. This is the temperature control unit. It consists one pump, one heater, and this is the thermostat. And this is the coolant. The coolant, when coolant is heated, it passes from this pipe and circulate through the heat exchanger. When coolant is passes through heat exchanger and it maintains constant temperature, the thermostat, this thermostat will disconnect the connection between pump and heater.
This is our TGSD, temporary gas storage device, which is directly connected to the digester by means of this pipe, T connection, and the ball valve. Now, when this will be fully filled by the biogas, this will like this, and this will be collected by us. Then it will take for the filtration. Now I show you why we require filtration process. Please come inside. This is our filtration area where we filter the biogas. In raw biogas, there are some impurities like carbon dioxide, hydrogen sulfide, and some water vapor. Here are some equipment which are used for the filtration process. This is the equipment for the carbon dioxide removal. This is the equipment for the hydrogen sulfide removal. And this is the equipment which is used for removal of water vapor This is called condensation trap. I will show you first how we remove the carbon dioxide. In this drum we use calcium carbonate. See, in this drum iron scrap is which is used for the hydrogen sulfide removal. This is our condensation trap, in which we use for this equipment for water vapor removal. In this process, we pass the biogas from here, and water vapor which is mixed with the biogas will cool down and save here, and dry biogas come out here. Now I show the testing of the biogas.
I will show you how efficient this filtration process works. This polythene bag contains raw biogas. I will burn it and show the which effect done on this flame. See, please do. See, you can see the red flame in between this blue flame. This will show the impurities present in this gas, and this will show carbon dioxide and the H2O vapors present in this gas. After some time, we can see the carbon vapor store on the surface of the bowl, and let us see. You can see here, there is a carbon vapor stored in the surface of this bowl. This will prove these raw biogas contain carbon dioxide, and the odor of this biogas feel us that it will contain H2S. We will filter it through our different filters and show which effect done on this gas. Thank you.
Now for hydrogen sulfide removal process, we use this drum. In this drum, we use iron scrap. Now I show you how we remove hydrogen sulfide. In this TGSD, there is a raw biogas, and this raw biogas slowly pressed by, and this pass from this inlet. Now I show you slowly biogas passes from this inlet and coming out. Now in this drum there are some chemical reaction process and hydrogen sulfide is removed. Now at this outlet, the hydrogen sulfide removal biogas coming out, and this pipe is directly connected with this equipment. This equipment for the water condensation trap. In this water condensation trap, the raw biogas passes from this inlet and coming out from this pipe. In this process, the water vapor is cooled down and collected in this drum, and a completely pure biogas is collected in this TGSD. Start. Now you can see this raw biogas TGSD is empty and pure biogas is collected in this TGSD.
After filtration, we have this TGSD contains upgraded biogas. We use H2S filter and carbon dioxide filter and water vapor removal to remove the impurities from this gas. Now we burn this gas and show what effect done on this gas. See, this flame contains no red particles, and it is a pure blue flame like our LPG gas. And there is a, we can see after some time there is a no carbon traces on the surface of the bowl. We have no odor here. That will prove actually is totally removed from this gas. Okay. We will see. See, the surface of the bowl is a very clear. There is a no traces of carbon traces. So it will prove our filtration remove total amount of carbon from the gas and total amount of water vapor from the gas. This will prove our efficiency of our filter, and we can use this gas in our IC engine very safely. One nozzle welded at the outlet of the compressor and another nozzle is welded at the inlet of the compressor, and we use here pressure gauge. What we have done, we just attach pressure gauge in series to this nozzle connection, so we can see how much of pressure we can get. I will show you how it will compress. After switching this compressor, it will starting to compress this gas in this polythene into this LPG bottle, and we can achieve a pressure up to 120 to 150 pascal. 120 to 150 psi.
Hello, this is our actual workshop where we have done the actual experiment on this vehicle to set the exact air fuel ratio on the vehicle or for the running on the gaseous fuel. Come inside. Meet the garage owner Lalibhai. Hello Mr. Lalibhai. Hello Mr. Sanjay Bhai. This man provided us the space to experiment on this vehicle, so we are very thankful to this person. Now come to this side. This is our vehicle, Suzuki Max R100, and these are both of the pressurized cylinder in which we have filled the gas up to the 120 psi. These both are connected in series, and the common connection is given to this evaporator. This is our evaporator, which is the main modification in this bike. The main function of this evaporator is to suck the gas and maintain the constant pressure inside the cylinder. This is the outlet of the gas, which is directly given to the pipe after the air filter. This is our vacuum pipe, which is connected to the cylinder pipe, and this is our inlet. This is the evaporator. In this one bellow is provided which will suck the gas and throw out into the cylinder. Come to the other side. This is the air filter, and after that this gas pipe is provided. So the air will come after filtration and mix with the gaseous, and the exact air fuel ratio will enter into the cylinder and the combustion process will start. We have done the experiment on this two-stroke engine, and we have achieved the running of 15 to 20 minutes on the single cylinder. Now I will show you how to start this vehicle. Ajay will help you.
यार